So today we're gonna go through the recent contest that was in Code Hacks, the Spark and contest. I know that many of you participated in this contest, and I also made a Twitter post to see how many people want me to create a live stream again, because I got good feedback on the previous live stream, and everyone in the community said it was very helpful to progress in their auditing journey. And that's why I decided to jump into this contest as well and participate. But before we do so, do you guys want to see my findings for the previous contest, like pretty quick, like how much money we got for it? And because it's like basically findings that I shared with you in the previous one. All right, so considering I spent few hours, it's not too bad for this kind of results. But as I told you before, I participated in the Foundry stablecoin one and the Code Hacks escrow. Mainly I participate in contests so we can make those live stream and educate the community and show you how I take the thing that you learn in the smart contract hacking course and apply it to auditing contests. So this is why I mainly participate in those small code bases contests, because it's easier for you also to get started and make those live streams. Now, if you remember in the previous stream, we talked about the DeFi stablecoin, the contest, the first finding was wrap BTC positions can never be liquidated. If you remember, there was a decimal issue. The decimal number was hard coded and it made all kinds of problems. Now, the core issues was the same, and I reported it in 3 different times because it existed in multiple functions and the outcome was a bit different. But as you can see, those 3 findings defined as self-duplicate, because the core issue is the same. The way the protocol treats decimal numbers in collateral tokens, then I wasn't rewarded for these ones. As you can see, 0 USDC, and for this one, but I got reward for this one, 90 cents, guys. This is this is very low, I know, but it's not bad. It's still something. I guess a lot of people reported this one. You can see here the result. This is the actual finding that was selected for the report. So you can open it and see how many people submitted it. It would be cool if they had here the number of total people that found it, like a count. And you see everyone got 90 cents apart from this guy over here. I will zoom in a bit. He got 30 cents more because his report was selected. Now it's very low amount, even though it's high severity finding, because many people found it. The more people found it, the lower the price gonna be. There is a formula that they use. So if there is a unique finding or 2 or 3 people found it, then the reward would be significantly higher. Even though it's high, you see, I got only 9 cents for it. And the second one was Medium, that USDT can never be supported by the protocol. If you remember, they used, instead of using the safe transfer lib by OpenZeppelin, they checked the return value and revert in case it was false, and it would break tokens that don't follow the EAP20 standards like USDT, which don't have return value, which means that they will return false by default, even though the transfer succeeded. And this, I got rewarded 12 cents. It's actually the post that I posted today in Twitter about this particular funding. It's a Medium. Again, a lot of duplicates, therefore the reward is very low. Look how many people reported it. So it's only $5 in total to all the people who reported it. And then the next one, remove ending user health factor check in liquidate function. Now this is funny, guys, because this one I was reported as gas optimization, but it was upgraded to Medium because there was some kind of security issue here. And even though I reported gas, look, I got $22 for this one, because I reported as gas optimization, but it was classified as Medium, and also not that many people found it. We can see here how many people found it, maybe 10, around 10. So you see the price is higher than the high that we had. The high was 50 something dollars, and here you have $230, even though it's Medium. It's more important how many people actually reported and found it. This one, obviously, use of floating pragma, only 4 cents. Here we have zero address. DSC engine can be deployed without supported tokens. I reported it as Medium. It was downgraded to low, and I got 9 cents for it. Gas optimization, 11 cents. And this one, gas optimization, I got $4.5. So I got more money for gas optimization suggestion rather than high severity. So I think in total, this one got around $30 for the Foundry stablecoin, which is nothing. It doesn't worth the time, but it was worth the experience and the educational process. You know, see, it's still like not unique findings, but high, medium, low, and gas, all kinds of findings, and we covered them in the previous one. Now, if you want to find the unique ones, you really need to dive deeper and be more creative, which I hope this is the case that is going to be in the Spark N contest, the findings that are reported. We will cover them today. This is the purpose of this session. But before we do so, let's go to the CodeHacks escrow contract. This was the 40K contest with the contract that is responsible for the escrow that will be used in the CodeHacks marketplace, auditing marketplace later on. And I reported 3 vulnerabilities. 2 were accepted. 1 was not. Yeah, I could appeal for it, but I just decided not to invest time into it. I don't have time for that. I'm very busy at the moment. But you can see that here, one of them was selected for the report. So this is the medium severity that got accepted. As you remember, arbiter and seller and buyer shouldn't be the same. And it got $6 in findings because many people reported this one. Again, a lot of duplicates. So we got only around $300. And as you can see here, this one, I got more money, less money. It's gas optimization. So it was like, there was one finding that I remember that I got $55 for, and it disappeared, which I don't like. Or maybe I just missed it. Wait, where was it? I think because of the escalations or something. I don't know what's the deal, but I remember there was another finding that got rewarded for $55, and now it's disappeared. You see, that's what happens when you don't follow the escalations period. Well, I guess. Oh, this one. Yeah, sorry, this one. Oh, this is the high in the stablecoin one. It was a high that I reported that was more unique, so I got $51 or $52 for it. Users can be liquidated when their collateral value significantly dropped, because the way the liquidation works, there was an underflow, if you remember, in the previous live stream, and this one got rewarded with more because less people found it. And I will tell you even more, there was another high severity that was reported that everyone who reported got around $1,000 for it, but I think it's duplicate. It's the exact same one because all the people that reported this reported the other one. It's very, very similar, but I think there was some kind of issue. If we go to the main report, if we go to the Foundry stablecoin and to the final report, there was another one that is very similar. Okay, full liquidation is not possible. You see this one, liquidations allow for too much debt to be, no, this one, sorry. This one is legit. Yeah, full liquidation is not possible when collateral ratio is below 110%, and it's exactly the same issue. Yeah, you see it? It's the same issue here. The underflow that we discussed last time, because the amount collateral will be greater than the actual collateral that was deposited in the mapping here, there will be an underflow. So exact same issue, but these guys were lucky to get around $300 each, $350 each. This is the only one that I appealed and said that it's the same issue. It's not supposed to be treated differently. I'm sorry for all the guys that reported it, but yeah. We saw, so in the stablecoin, I think I got around $100. This one around $10 because here it's like 6 and here it's like 3.77. But guys, you have to remember that when the competition is high and especially the excitement around CodeHacks, there were many participants. The pot wasn't that high and I didn't invest so much time. I didn't expect to get a lot of money. I just wanted to find the easy ones, the ones that are obvious, to show you that you can also do it. You can also make $100 participating in the Foundry DeFi stablecoin. All these findings, you could find them as well. You could report them as well. And if you even would invest maybe 2 or 3 days, maybe you will find some unique findings. Why I say this? Because it's literally possible. We have Chris in the community. I don't know if he's now in the live stream, probably not. But if you look, we have a lot of students that were able to find uniques and get very nice rewards. In the Beetle one, for example, I got around $20 and Chris got the second spot, $1,700, which is incredible. He's like a student. We have here multiple students here in the top 10, top 20. So I'm super proud of you guys. Van Grim, also a student of the course. A lot of people that are just killing it. So we have here multiple students. It's definitely possible. I highly recommend you to try it out once you complete the course, or maybe even during the course. All right, so this is the Spark and contest. As you can see, this is the most recent contest that just closed a few days ago. It was $15,000 pot. And what is SparkN? Let's start with what is SparkN. It's a protocol, a Web3 project that aims to build a marketplace for anyone who wants to solve their problems or anyone who wants to help solve problems. As a first step, we have created the protocol. The details of how to use the protocol is up to the users. This team is a graduate of the Foundry Full course on YouTube with 15K up for grabs. So the creator of the course learned from Patrick Collins how to code, and this is good because it means that the code was pretty legit, pretty solid, pretty documented, a lot of comments, errors, modifiers, event, very nice, well written, well structured, very well tested code as well, which is nice as an auditor to come to a code that is looking nice. I will just explain what is this project in very short paragraphs, so it will be easy for you to understand. So let's say there is a project that you want to initiate, okay? It could be, for example, I don't know, designing a new website or creating a new website from scratch. So you can go to SparkN, which is a protocol, and then you can announce a new contest of like the one who designs, or 10 people that will design the best logo or the best website are gonna win a prize. Then you can decide how many tokens you want to put in this contest. And you, as the contest organizer, you send the tokens to a predefined, pre-created smart contract that holds these tokens. Now, you as the organizer can come later on, provide an array of winners and percentages. For example, who are the accounts? The winners are just addresses of accounts that participated in this particular contest and won. They had good designs maybe, or they did a good job. And what are the percentages that every single one of them are gonna get from the contest? And then it's gonna send the tokens to these winners. So this is just, you know, in general, how it looks like. What is this SparkN all about? To make like decentralized contests. Now, it's cool and nice that we say decentralized contest, but this is very kind of centralized, similar to the escrow contract that we had in the previous contest, because the organizer can decide who are the winners. Also, we have an admin here that if the organizer failed to send the rewards after a few days, after a certain time, then the admin can initiate the reward distribution and decide who are the winners and how much money they get. So it has a lot of central points. And if you went to the CodeHacks Discord community, you would see that the owner and the administrator are trusted. And a lot of people complain that because the owner and the administrator are trusted, it removes a lot of attack surface and it's very hard to find vulnerabilities, which is completely true. Yeah, because it's completely true. When everything is handled off-chain, all the winners are being decided off-chain, the owner is like an account that controls it, and you have the admin account, then everything happens off-chain. Then on-chain, you don't have what to do, because if you say the owner can rug the winners, they would say the owner is trusted, or the admin can rug the winners and take the money for himself, they will say the admin is trusted. So it really narrows down the attack surface and the things that you can report or the issues that you can find in a smart contract. But if you go creative enough, you can still find issues in the smart contract. And I think I was able to get some interesting findings. And I will share them in a moment with you guys. And I will be more than happy to hear yours, because as I see, some students are even more creative than me and are able to find more unique and interesting findings. So I'm totally up to listen to you and see what you guys found. That's why it's a live stream and not just a lecture by me. So if you want to share your findings later on, go on camera, go on with speaker, please do that. All right, so this is how it looks like. This is the diagram. And it works with proxies. In order to save gas, they use proxies, and you have a factory contract. So this is the entry point, the factory contract. All the transactions supposed to go through the factory contract. All the other contracts we are not supposed to send transactions to them, but only through the factory contract. Now, as you can see, we have the owner and we have the organizer or other sponsors that want to sponsor the contest. So the organizer basically, the owner first need to set a contest. It's another centralized point. Organizer cannot just come to Spark and protocol and initiate new contest. The owner needs to approve it. So there is one owner, one admin, one account that decides which contest happens and which one doesn't, which makes it completely centralized in my opinion. But this is the way they decided to implement it at the moment. And if you report something about it, it's probably going to be rejected. So the owner calls the set contest function. Okay, let's see it in code how it looks like. So we have the proxy factory. Okay, this is the main entry point. I will increase the font size so you can see it better. Please let me know if you see it better. You want me to increase or decrease the font size? Tell me if everything makes sense. So this is the proxy factory. As you can see, it's ownable. It uses EIP 712 for signatures. You're supposed to be familiar with signatures if you went through the replay attack section with ECDSA and EIP 712. And here they defined errors. We have here two events for set contest and distributed. Here we have two constants, expiration time and max contest period. So contest can be up to 28 days and expiration times, we'll get to that later. We'll see what it means. And here we have sold to close time and whitelisted tokens. So basically when they deploy the contract, the factory, the main entry point, remember, they decide what tokens can be whitelisted and can be supported by contest. So only the tokens that will be supported, which they said it's going to be GPY because they're from Japan, or USDC. Here, you can see it here. It's mainly stable coins. Only you can create contests with these kind of tokens. You cannot create them with other tokens because it's going to be added to the mapping here in the constructor. And if it's basically not supported, you cannot create contest with this token. And as you can see here, I already wrote two audit issues, okay? So I said that ERC77 tokens are supported, okay? And reported, I just reported this as a finding. And also that there are no ERC20 interface checks. So there is address 0 check, but there are no ERC20 interface check. And it can be done using EIP 167. We'll see that later in my finding. But basically, you can send addresses that are EOA accounts or just contracts that are not tokens. So it's usually when you add tokens to be whitelisted, you want to make sure that they implement the ERC20 interface and they don't implement ERC777 unless you want to support ERC777, which is not a good idea because you will see in a moment why. Any questions so far regarding the constructor, the proxy factory? Please ask them in the chat. All right, so this is the set contest function that we saw over here in the diagram. So the owner called the factory and sets a new contest, and he passed the following parameters. So he passed the organizer address, okay? So the organizer needs to come to the owner of Spark and Protocol and tell him, I want to start a new contest. He cannot do it himself. So he passed the organizer, the contest ID, it's some kind of a random hash, 32 bytes. It will be generated off-chain. And we can see if you're not sure about what it is, you can always go to the tests because they had tests for everything. So if we go to unit tests and I think it was, where was the tests? Maybe integration. Yeah, integration. And then you can see set contest. And you can see how they generate the ID, you see, over here. So basically, they take just a JSON 001, they encode it, and then they do KECAC 256. They just make a hash, and this is going to be 32 bytes, and this is going to be the random ID. So there could be collisions, but basically, if they use different strings here, the hash, just if they had one number, it will be completely different, because the KECAC 256 is pretty good hashing function, so it shouldn't be a problem. But just so you know, so you can get some context of how a contest, what is contest ID? Close time is when the contest is over, and implementation. What is implementation? We will see in a moment. It's the implementation contract that will be used to distribute the rewards. Here, we make sure that we don't have address 0, no organizer, no implementation, or we raise an error, we revert an error with no address 0. We make sure that the close time is greater than the current time plus the max contest period, and that it's not lower than the current time set, not some time in the past. So here, as you can see, I just want to see if there are some issues with the timing, and I checked it in my mind or in a notebook, and I see that it's okay. So I added an audit okay, close time validation exists and is okay, so I won't go back to it later on. So it's also useful to add this kind of audit okay comments, so you won't spend time over and over again to check the same code section that you already checked. Now here they calculate some kind of salt that is based on the organizer, contest ID, and implementation. So we can also jump to calculate salt to see how they do that. Let's just go to calculate salt. It's a function here. Again, it's a KCAC hash of combining all these parameters. So it will be unique. The contest ID or the salt of the contest will be unique based on the organizer, contest ID, and implementation. Now we can go back. And they set the new contest. They don't save all the contest details, but they save only the salt and the close time in this mapping salt to close time, as you can see. Now they check here if this salt exists. This is how they check it. So they make sure that they don't have to do the same contest or they don't overwrite contest. So if you reported something like contest can be overridden and money can be lost, no, it's not valid, because this line of code makes sure that we have this salt is unique and this contest is unique, as far as I see it. Because if it's not unique, the close time would not be 0. Then they set the close time and emit an event. So this is how the admin, only the admin, as you can see, it's protected by only owner, one EOA account, or maybe multi-sig wallet, I don't know, can create new contest. Is that clear so far? So this is setting a new contest. And then after we set the contest, now there are a few things that can happen. We are going to deploy the proxy and distribute. What does it mean, deploy proxy and distribute? So we have the proxy factory contract, and we have this proxy contract, which is very simple, very thin. They just use the OpenZeppelin implementation. They copy the code and use the same exact proxy thin implementation. So this is simply just a proxy contract that forwards all the calls to the implementation contract. And if you thought that the implementation could be overwritten or stuff, no, it cannot, because it's immutable. And if you followed my sensitive on-chain data chapter, you already know that immutable variables are going to be stored in the bytecode itself. So you set them here in the constructor and they will be stored in the bytecode. They are not in the storage of the smart contract. So with upgrades, with delegate calls, this cannot be changed or be corrupted or overwritten. So it's totally fine that it's immutable here. And as you can see, there is just one single fallback function that forwards all these calls with delegate call to the implementation. Now, there could be multiple implementations to distribute rewards in the contest, but they implemented this kind of first implementation distributor, and this is what the proxy is going to forward the calls to. And as you can see, this distributor has a constructor, which is the factory address and stadium address. Stadium address is just a fancy name for the account that's going to get fees for all the contests. So the Spark and platform are going to get a 5% fee from the pot. You can see it here, commission fee. It can be changed in the future, but currently it's 5% or maybe 0.5%. I think it's 0.5%, but I'm not sure. We'll get to that later. Going back to the proxy, so the way it works, imagine that you send a transaction to the proxy factory, then it deploys a proxy here that points to the implementation, which is this contract. So there are in total 3 contracts, but you cannot call the proxy directly. It will not. It can work, but it won't do anything, because in the distributor contract you have access control that makes sure that the message sender is the proxy factory. So you cannot call the distribute funds manually, because you have this kind of checks. If message sender not equals factory address, if the entry point is not the proxy factory, then the transaction will be reverted. So all the transactions should go through the factory, or you can do nothing about it. Now, how it works? So there is a new contest. Let's say it's 1 month. Then when it's over, so what happens is that the owner or the organizer of the contest are gonna send the money to pre-computed address. Since it's proxy and we deploy it later, we can compute the address in advance. Because we deploy the proxy, let's see how it looks like, with this kind of a new command. This is like create to, okay? Which means that you can predict the proxy address that you are going to deploy for the contest before it's actually deployed. So the way it works is that first the admin of the protocol sets the contest, then the organizer can retrieve the address of the contest, the proxy of the contest, send the tokens to this address, and only once the contest is over, he can deploy the proxy. So we send the money before we deploy the proxy, like the escrow contract, deploy the proxy and distribute the rewards, right? So you can see it also in the diagram. So first he set the contest, it's called, and then the organizer sends the tokens to the proxy contract or to the pre-computed address. Then it calls distribute function again through the factory. You cannot call it through the proxy or through the distributor. The factory calls the proxy, which delegate calls to distributor, which makes sure that it was through the factory. And obviously, the tokens are being held on the proxy, not in the distributor, because it's only the logic contract, the implementation, and the tokens get distributed to the winners or supporters that participated in the contest. Now let's see. So we already understand how we deploy and how they work with each other, the contracts, how the organized set contests. Let's see how the distribution works, how we actually deploy the proxy contract and distribute the tokens. So we have few ways to distribute the rewards. The first one is deploy proxy distribute. This one, okay? Deploy proxy and distribute. So this function should be used by the organizer of the contest, the one who created this contest and want to send the money, or the sponsor. And let's see what happens. It receives the contest ID, implementation, and call data, okay? It makes sure that the message sender with the contest ID, with the implementation, this salt exists. What is the message sender? The message sender is the organizer. So it makes sure that there is such contest set for the message sender as the organizer, the ID, and the implementation, and it makes sure that it's not 0, because if it's 0, it means that the contest does not exist, and it reverts with contest is not registered. Then it makes sure that the contest is over. So it takes the salts to close time. This is basically the close time, and it makes sure that it's greater than block timestamp, right? Because he cannot send the tokens if the contest is not over yet. And then it said contest is not closed. Then it deploys the proxy and calls distribute function to distribute the tokens and return the proxy address. So deploy proxy, we already saw how it looks like. We calculate the salt. It's the same salt, organizer, contest, and implementation. And we use the new command to deploy the new proxy contract. We import it here on the top, the proxy contract. So we deploy a new lightweight contract. We don't need to deploy any contest, the whole logic. The logic exists only once. And because we forward here the implementation address, we don't need to deploy the logic over and over again, but we just deploy a cheap contract, just the proxy contract. And now let's see what happens in the distribute function. So we jump into the internal distribute function. It receives the proxy and the data, and it just makes a generic proxy call with the data. So it's simply just gonna call the proxy with the provided data. Now in this data, we should encode basically the function that we want to call in the distributor. I know it's a bit confusing, but bear with me here. So in this encode data, we need to encode the sig hash function and the parameters that we want to send to this distribute function, because if you remember, it calls the proxy, and the proxy is gonna do delegate call here to the distributor, okay? So as the distributor, we need to prepare off-chain all the data. Probably the UX is gonna do it for us, but the data is gonna be sent to the proxy here as the data, the fallback, and will be forwarded in the delegate call. Eventually, it will be called this function, distribute function. So this is how it controls the data, and inside this data, there are going to be also the parameters that are being sent to the distribute function, which is the token, the winners, and the percentages, and some extra data if we want to pass it. Why? I don't think it's being used, this extra data. Yeah, it's just useless data. They're just going to emit it in the event. So this extra data is not being used. I know it's a bit confusing, this flow here with delegate calls. It's a bit advanced. The second way to distribute the rewards is this one. Deploy proxy and distribute by signature. What it basically means, so if the owner of the organization is cheapy and he don't have money to pay for gas, he can make a signature, sign a message, give it to someone else, to another account, so this account can just distribute the rewards. Okay, this is the way it works. It's similar to permit in ERC20, but just for the action of distributing the tokens, which is pretty cool feature. And I wanted to find bugs here. I almost did, but then it was false positive. I think I posted about it on Twitter. I will tell you where my mind took me and why it was false positive. So this function receives the organizer, the contest ID, the implementation, signature, and data. Now remember, inside this data, we have the winners and the percentage arrays. So if I can send malicious data and I can say that I want to send all the tokens to myself, I'm a single winner, then I can just steal all the contest money, right? But I cannot do that because there is a signature here. Even though, you see, it seems like there is no access control for this function. Anyone can call it, and there is no message sender check, there is nothing organizer, admin check, but the signature here is the catch. So what happens? We're gonna take the contest ID and the data, and we're gonna hash it, okay? Now, we cannot do replay attacks here because we use hash type data v4 and we use ECDSA library by OpenZeppelin. We covered it in the call attacks chapter, and this library already aids a domain separator for us, as you can see over here. So as you can see, it's gonna add the domain separator, which includes the blockchain ID. So if it's deployed on multiple blockchains, the signature will be different. It won't be the same because we have different chain ID. So that's why if you reported replay attacks are possible with a signature, it's going to be invalid and it's going to be rejected. Any one of you reported something like that there might be replay attack, don't be ashamed. It's okay. We are here to make mistakes and learn. So if you reported some kind of replay attacks, I'm sorry to say, it's going to be invalid. And this is the hash, this is the digest, and then we take the signature and we try to recover this digest, okay? And then we make sure that it's the organizer. So basically, we make sure that the organizer signed this data. If the organizer did not sign with his private key this data, we will revert the transaction. So this is the access control that we actually have here. Now, initially, I thought that because we don't have in the data in the signature the organizer account or the implementation, we can basically decide on different implementation or not be the organizer and bypass it. But no, it's not possible because if this data is not the data that the organizer decide, which the data includes who wins the money, who wins the prize, if it's not what the organizer decided, then this validation won't succeed because the signature should match the digest, which is based on the data. So we cannot just change the data, change the winners array or the percentages array, because if the data will be different, the digest, the hash will be different, and if the hash is different, it will not match the signature and we will fail. So this is the false positive that I almost reported, but then I saw it's a false positive. So now the salt is, again, it's based on the organizer, contest ID, and implementation, so we cannot miss up with the implementation, right? Because if you will send an implementation that is another smart contract, then the salt will be different and it won't exist in the mapping and it will revert because the context is not registered. So doesn't matter which parameter you are trying to play here. This is usually when I put the attacker, the black hat mindset, I'm trying to figure out what inputs I can affect the functionality of the function. Maybe I can put different implementation. Maybe I can change the data. Maybe I can send malformed signature. And I really went through this function and I couldn't find anything that I could do, because if I change implementation, the salt will be different and the context won't be found. If I change the data, the signature will not match the data. So if I change the organizer, again, the salt will be different and also this will be different. So I cannot play with any parameters. If I change the context ID, again, the digest will be different. So it's really tight. It's very good like approach. The developer thought about all the edges, and it seems like you cannot really play with the parameters. Were you able to trick this function somehow? I don't know, or any vulnerabilities around this signature validation? I would be very interested if you came up with a creative idea to break this distribute by signature function. Basically, I didn't have some kind of systematic approach where I just have a notebook and I try to think what parameters I can change. So if I can change the implementation, it means that I can call a different smart contract, right? So it means that instead of running this distribute logic, I can write my own smart contract with different distribute logic and take all the tokens to myself. But I say, okay, if I can change an implementation of my own, it would be bad because I have an idea on my head how I would use it to steal the money. But then I see, okay, what happens if I put a different implementation that it's a malicious contract that I deployed? And what I see is that the salt will be different. That's it. This edge is closed because if the salt is different, it will be reverted here because the context is not registered. So I just check one by one on my head with a notebook. Okay, what if I change the organizer? Will it give me something? Probably not. So it's not interesting. What if I change the context ID? Will it give me something? Probably not. But even if it would give me something, I cannot do that because if I change the organizer, it will affect the signature recovery. If I change the context ID, it will affect the hash, which will affect the signature recovery process. If I change the implementation, it will change the salt. If I change the signature, well, it will be broken. If I change the data, again, the signature comparison will fail because the hash will fail. So this is how I do it. I just try to go through every parameter and see how I can affect it. What if I change the message sender? Will it affect? No. Message sender is not even considered here. So I go through every input that I can affect the function and try to check it. So again, we do the same thing. After this is, if you can separate this from this. This is just the exact same code from here. You can see the same from the previous function. So we just to deploy the proxy with the organizer, context ID, implementation, and distribute. This could be extracted to another external function just out of readability because it also happens here again and again. You have redundant code here. As you can see in this next function, we'll see it in a second. But this, you see, these 3 lines of code are the same. It's just to deploy the proxy, distribute the funds, and return the proxy address. So it happens in all the functions, these 3 lines of code. Now, the next thing, which is another false positive that I thought I could report, is deploy proxy and distribute by owner. So the creators of the project, they thought, okay, what if the organizer disappeared? He sent the tokens to the contract, but he's not responsible. He's not willing to distribute the money. Okay, we want a way to rescue the funds from this smart contract. That's why we have an owner, and it's only owner protected function. And then the owner can distribute the money to the winners, okay, if the organizer failed to do so. Now, I thought when I look at this function, wait, but what if the owner private key is compromised? It's very strong power. Maybe you can use this function to decide who are the winners for all the contests in the platform, right? Because this owner can do that. So I said, what if the owner private key got hacked? And what if I wrote a script that every time when the contest is over, it will distribute, doesn't matter, all the contest. I call this function and I even front run the organizer as the owner of the protocol, as the owner of the Spark and contest protocol. I will front run the organizer and the sponsor, and I will just gonna steal all the money from this proxy contract to my account. And I thought that, okay, the organizer failed to do so, add a time lock, right? So the owner cannot right away distribute the money, but only after a certain amount of time when the organizer failed to do so. And I thought that these checks are the same for the organizer and the owner, but apparently it's not. Because here it should be greater than block timestamp, and here it should be greater than block timestamp, but plus the expiration time. So there is a time lock. The owner cannot distribute the money right after the contest is over, but there is some extra expiration time that basically we give time to the organizer to distribute the funds, and only if he failed to do so, then after 7 days, the owner can distribute the money to the winners. And somehow I missed it, and as you can see, I added here, should be only if organizer fail to distribute the rewards, and we need to add another time lock. In case admin key is compromised, he can get all contest pots to himself. But they actually do it with this expiration time, but I thought that this expiration time is to something else, and I actually wrote an entire high severity finding, and I just really invested a lot of time on it because I thought it's going to be unique and smart, and then I just was stupid. And because I invested so much time in writing it, I didn't even remove it. It's this one. A time lock is required for admin distribution actions. And I just was very proud of the report, so I wrote here, just figured out that I got it wrong, didn't want to remove the text because I invested a lot of time in reporting it, and I like the way it came out, even though it's wrong, lol. So I didn't remove the submission, I just wrote here for the judge that I know it's false positive, I know it's a mistake, but I just spent so much time writing it, and I even added here code suggestions, add owner time lock, and add it to change the if statement, add this owner time lock. So anyways, yeah, this is a fail on my end. So you have here deploy proxy and distribute by owner, and you have another function which is only distribute by owner in case the proxy was already deployed. So just another way to do it, but also here, as you can see, they add the expiration time. So the owner cannot call it if 7 days did not pass until the contest is over. So the organizer have the first priority to distribute the funds, and only after 7 days, the owner of the protocol can do that. So this is the exact same thing. I didn't find any issues here. Now, here I found a high severity issue. I think it will be quite interesting, and I want to hear your thoughts about it. This is the first issue that I reported. So if you remember, the organizer is sending the money, the tokens, to pre-computed address before the contract is deployed. And the way it works is that it's going to utilize this function, get proxy address. It's going to send the sold of the contest and the implementation, and it will return the proxy address. Okay? And all the explanation is here. The docs are pretty good. And if you think about it, imagine there is a DApp, a web application, SparkN, and you are an organizer and you have a step-by-step process to create a contest. And then they tell you, all right, now the contest is created, it's registered. Now it's a time to send the tokens. And they present an address for you to send the tokens. These tokens are going to be sent to this pre-computed address, and they're going to utilize this get proxy address function to get this address that will be presented to the organizer in the front end that is supposed to send the tokens to. Now, what if this function returns a wrong address? The tokens will be lost forever, and you will see in a second how easy it is to get the wrong address. And this, in my opinion, is high severity, because if an organizer sends tokens to a wrong computed address, this money will be lost. It's loss of money, and it's high severity. And I think that also the likelihood of this to happen is high due to the way they designed this get proxy address function. Now, I want you to take a look at the get proxy address function and tell me, why do you think the likelihood is high, and why it's problematic the way they design this function. So take 1 minute, take a look at this code. I also recommend you to clone it locally if you didn't participate, and take it a look locally for better quality instead of going through the live stream and pixels. So you can just clone the code locally and take a look at this get proxy address and tell me what could go wrong there. It's just a public view function. It's not even a function that's going to change the state, but it's still, in my opinion, it could be catastrophic. And this is my report. It's a very detailed report. I'm very proud of it. I hope it's going to be accepted. I hope it's going to be unique. I don't know how creative it's going to be and how many people reported it. We can actually search here in the issues, but I didn't do that yet. As outlined in the project README, when the owner initiates a new contest, the organizer sponsor is responsible for sending tokens to a predicted proxy address. The address is determined by combination of the generated salt, which relies on organizer, contest ID, and implementation, and the implementation contract of this. This is basically, I describe what happens over here. You see, it's based on organizer, contest ID, and implementation. This is the salt, and also in the implementation. And this is the get proxy. Again, salt and implementation. And as we know, salt is based on organizer, contest ID, and implementation. So these 3 parameters. Now, the organizer sends the tokens prior to the proxy deployment by using the proxy factory get proxy address. This is the function that we just see. It's a view function to send it in advance. However, the problem is that this function lacks a verification mechanism for the accuracy of the provided parameters. So doesn't matter what is going to be sent here, which salt or which implementation, anyways, this function will return some kind of address. It's anyway going to return an address because this cannot fail. It just, just functions, ABI encode packed, uint, type. There is no revert, no require statements. Whatever values you're going to send here, whatever 32 bytes and address, it's going to return you some kind of computed address. And now we'll see why it's bad, because it needs to have some kind of verification mechanism. This can lead to situations where the organizer inputs incorrect parameters, resulting in the receipt of inaccurate proxy address. And if tokens are sent to this wrong address, they will be lost forever. So since there is no verification, the organizer can send invalid salt and implementation. Now you might say, wait, but it will be handled off-chain, right? It will be handled in the front end. Let's try to think how it will be handled in the front end. The organizer will connect his wallet to the website, and based on his wallet, the organizer address will be retrieved from the connected wallet to the website, right? And they're gonna generate the salt on the front end. The salt is being generated, how? Based on organizer, contest ID, and implementation. Now, what if he connected the wrong wallet to the website? What will happen? The salt will be different. And if we send different salt to this function, the address that we will receive will be different. So if we connect the wrong wallet to the website, and we know how easy it is to connect the wrong wallet using MetaMask, we'll send a wrong salt. And if we send a wrong salt, we'll get a wrong address. And if we get wrong address, we send tokens and they are gone. Now, what do you think is the likelihood of something like this happen? So this is basically what I explained here, why it's very likely to happen. The likelihood is high, the impact is high. And my recommendation is actually to store contest data in the proxy factory. Instead of storing only the salt and it can be solved on-chain. Why do you want to solve it off-chain? It can be solved on-chain for not much gas, nothing basically. Instead of storing only the salt and the close time, make a struct of all the contest information. It will be also easier to retrieve it than on-chain, off-chain on the website, because currently you don't have some kind of database that stores all the contest information. You need to store it in an external database, not on the blockchain. All this data of contest ID, close time, implementation, organizer should be stored on the blockchain. And if you're storing it on the blockchain, then you can add a require statement. You can get a contest and make sure that the implementation is not the implementation and the organizer is not the organizer. Then you can revert the transaction. So you want to make sure that you save all the contest information on the smart contract and the factory contract. So if someone calls, this get proxy address view function looks very innocent. but if someone calls it with a wrong salt and wrong implementation, it will return a wrong address, which is bad. It might get a lot of tokens get lost. So just add another required statement that makes sure that the organizer, the contest ID, the implementation exists, and revert if it fails. So this is the recommendation. I hope it's going to be approved. I hope it's going to be also selected because it's a very nice report and very nice recommendation. So this is the first high. I think that the calculated address might be wrong and tokens might be lost. The second high is not good. It's a false positive. I just left it. And here we have 2 mediums and 2 lows. Let's go to the lows because it's very easy. Remove commented out code. There was some commented out code. I put it as slow. I don't know if it will be accepted. Missing ERC20 interface checks on whitelisted tokens. Also, we talked about it already here in the constructor. We don't check that the interface are ERC20 tokens. And these are 2 mediums, and it's regarding DOS attacks on the distribution, how one winner or one token can make a DOS attack. Let's start with the easy and the more obvious one. I don't know why they did it this way, why they don't want to change the data of the contests on-chain. It's actually pretty odd for me, but I think it's not going to be that expensive to store the contest detail rather than only the hash. Maybe it's a bit cheaper in terms of gas because it's storage, you know, in the contract, but it makes problems if you don't store the contest data because these mistakes might happen. And no, the answer is no. I also thought about this attack scenario, Luis. It's a good attack scenario, good way of thinking. I thought, okay, what if I front run he sends the tokens in advance, right? So what if he sends a token, I see the precompiled address, and then I deploy the contract myself and get the tokens, right? This is what I thought also. It's a good way of thinking, Luis, but it's not possible. I will show you exactly why. Because the way the new opcode works. Let's see. So how the proxy is being deployed, how the address is being determined. You see this new. So it's not only based on the salt and the implementation, but it's also based on the contract that deploys the contract, which means that you will not be able to get the same hash if you deploy it because the factory has, when the factory is deployed, it has its own address. And when it deploys other contracts, his address affects the address of the new contracts that he deployed. So it's not possible to deploy the same address. Because imagine like he has some kind of, when you deploy a contract, you get what I'm saying? When this factory deploys the contract, you cannot deploy the same address. So when this address will be predicted, you cannot deploy it in advance because it's based on the address of this smart contract. And you can see it over here. You see address this. We use the factory contract to determine the deployed address. And you don't have access to this factory contract. You cannot deploy contracts from this factory contract. You can deploy it from your own machine, from your own EOA account, from your own smart contract, and you cannot basically have address this. All right, so the next one is, remember the first thing that I said about ERC77 tokens, that it allows ERC77 tokens. Now, if you went through the reentrancy chapter, you know that with ERC77 tokens, we can control the execution flow because we can add hooks to the receiver and to the sender, to before the tokens sent, after the tokens are sent. And why is this problematic? Because if we go here to the distribute function, basically, the way it works is that we call this external distribute function, and then there is the internal one, and we get the token, the winners, and the percentages, and the data is just going to be emitted in an event. So let's assume this is an ERC77 tokens, and one of the winners is malicious. One of the winners want to screw everyone else and make sure that no one gets the tokens. So what is he gonna do? The winner, the address, it's gonna be a smart contract, okay? It's gonna be a smart contract that has a hook for ERC77 transfer, and it's just gonna revert the transaction because here, as you can see, we use the safe transfer. So we go through all the winners and eventually we'll get to this malicious winner. We'll try to transfer the tokens to the winner. And then if it's ERC77 tokens, we will have a callback that will trigger a function in the winner address. Now, this winner address can just revert the transaction or just waste all the gas, okay? So one winner can screw all the other winners in case it's ERC77 tokens. Now, it's not high, it's medium, because the likelihood of using ERC77 tokens is not very high. This is one. And also, they can overcome it. They will see that the transaction is reverted. There is one winner that screws it all, and they can just remove this winner and try to send the transaction again without this malicious winner. So that's why I think it's either medium or low. In case they use cron jobs, it could be a medium because they will waste. I think it's valid, but not sure about its severity because they can call it again without the malicious users. Yeah, they can call it again without a malicious user. Basically, my recommendation here is simple. I even had a POC of a malicious contract. So the malicious winner can deploy this contract and just option 1 just reverts with no prizes for anyone. And option 2 is just waste all the gas. And the recommendation is to use EAP167 to ensure that there are no ERC77 tokens are being used. So you can use EAP167 to make sure that it's not ERC77 tokens in the constructor. And the other way to do it is to implement a system where winners can withdraw the rewards. Instead of push, it will be pull method, okay? So instead of the organizer is like pushing and sending all the rewards, he just decides who are the winners, and then the winners can claim the rewards later. It will require a lot of refactoring, so I said it over here that it's not recommended. Just don't allow ERC77 tokens, that's it. Okay, the next one is also a very interesting one, and it's basically distribution will fail and run out of gas in case of too many winners. Now, they don't accept in this contest gas optimizations, but I recommended to the dev in the Discord channel that here, this is very not optimized because here we do two for loops on two arrays. So we have the winners array and the percentage arrays. These are two arrays that their length should match because every percentage should match to a winner. And here we iterate through all the percentage to calculate the total percentage to make sure that it's not more than 100% minus the commission. And then we iterate through the winners again to send them the tokens, which is not very stupid, but not optimized. You can do the same for loop, same iteration. You can make this, send the tokens already here to the winners, and still that if you revert the transaction, it will revert the whole transaction, right? Even if you send the tokens to the winners, it's still going to revert the transaction if the percentages are wrong. So you can just combine these for loops, and this is one gas optimization that I just recommended. I didn't make an issue for it because they don't pay for gas optimizations. I just tell them in the Discord channel that is dedicated to the contest. But what I did find out that if there are too many winners, the gas will not, because of the way this function is designed, the gas will not be enough to cover the payments. So it cannot support a lot of winners. What could happen theoretically, potentially, there could be a contest with a lot of winners, but this function is just not optimized, and it just does not support many winners. And I even wrote a POC here, as you can see. This is a POC for Foundry. And as you can see, I created a realistic data because here they had a function that creates data, which wasn't that realistic because they used only 1 or 2 winners. Here I created an array with 9,500 winners using Foundry. And I gave every one of them 1% of the pot. And I use the GPYC. Let's go to the code. It will look better with syntax highlighting. So I will test out of gas many winners. So this is the function, test out of gas many winners. First, I use the create realistic data, which creates all the array with all the winners. And then it basically sets the percentages to all those winners. And then I encode the data. I just use their function to create my own data. And here I'm basically gonna forward it 9 days later and basically try to deploy the proxy from the organizer and set it with the data of all the winners and all the percentages. I make the assert to make sure that basically they got the 500 ETH. And also I told them you should run this gas with the realistic gas limit because it's going to be deployed in Ethereum. So if you run forge test with gas limit of 30 million, which is the current block gas limit in Ethereum, as you can see here, proxy factory delegate call failed, test out of gas, many winners. You see the gas? It was consumed, all the gas, 29 million. And here you can see also EVM error out of gas. So if you have a contest with 9,500 winners, let's run it. You will see that the transaction will be reverted with out of gas. So it does not support a lot of winners. Let's see how it looks like. You see, all the tests passed apart from this test out of gas, many winners. Now, I'm interested to think what do you guys think about this report, about this finding? Is it medium? Is it legit? Is it not legit? You know, I really tried to go creative since it's trusted, and I try to find like issues where the protocol fails. Tokens are lost, winners cannot receive their money, distribution will fail. And that's it, guys. These are the findings. So it's not crazy findings. It's just, you know, one high, two mediums, two lows, but they are very interesting, a bit out of the box, I think, considering the fact that the code is pretty secured and it's very centralized and trusted. I think it's not bad. Yeah, it could be not realistic and they can downgrade it to low, but I don't think so. It's like you have unbounded loop. 9,500 winners, it could happen. So, and there is a POC that shows that it's like, it fails. So I don't think it will be rejected, but we'll see. Yeah, organizer can be malicious, transfer 95% of the funds from contest contract to himself by passing on himself in the winner's array. I reported this one as well. Wait, I didn't report it. I wanted to report it and then I thought it won't be validated as legit one. So I didn't report it. I don't know if they will accept it because, yeah, they said that the organizer cannot take the money back and cannot refund the money, but he literally can because you can just call distribute with winner array of one account and percentages 9,500 and get 95% of them. And this one is similar to the ones I saw I went through the report in the escrow contract and I saw similar one that people reported it, and it's a very nice one, very creative, and I think it's legit. So if the token is USDC and the winner is blacklisted, then the tokens will be locked. But the thing is that the winner is arbitrary array, so I don't know if in that case you can just provide another winner address, and they can say, oh, this is off-chain. The winner provides his address, and that's it. So I'm not sure that it's valid in this time. In the escrow, it was valid. But here I'm not sure. Yeah, now it's a bit tricky, you know, with all the centralization when the protocol says that it's trusted. And well, you know, okay, the first finding that I reported with the invalid one that I basically edited and said that I got it wrong. If there wouldn't be time lock and the admin and the owner could distribute the money, the funds at the same time, this would be an issue because I don't care how much you trust your admin. The admin is not supposed to distribute the tokens instead of the organizer. There should be some kind of time frame where we give a chance to the organizer to distribute the tokens first because it can be trusted, but like you said, the key could be compromised and the MPC wallet can be compromised. I don't care. If you can restrict it on chain, on the smart contract level, do that. And they actually did it. They added this expiration time where the admin cannot distribute the money, but he can do it only if the organizer failed to do it in 1 week, which makes sense. So I think if you just generally report it like the admin is trusted, it's an issue, no, I wouldn't accept it as a judge. But if you say, okay, you can restrict the admin in the smart contract level, and in case of hack, it makes sense to restrict it a bit more, yeah, this is valid in my opinion. Okay, the sponsor can deposit more than one token in the proxy contract, which will lead to loss of funds after the distribute. The identified concern pertains to the proxy contract ability to accept multiple tokens. Okay, so anyone can send tokens to the contract. Why would a sponsor send tokens that are not set to the contest. It can do it, but also they said that in case this happens, the admin can call this distribute to save the funds. Wait, the recommendation. I don't like the recommendation, but I do understand the need. I think the likelihood is very low that someone will send wrong tokens. Usually there are functions to rescue the money. What about here? I think there is a function. If I'm not wrong, there was a function here to rescue. No, it's only this particular token. You're right, only this particular token. But the likelihood is very low, and also the recommendation doesn't make sense because token restriction. Restrict the proxy contract to accept only one token per contest. How? How are you gonna do that? This will prevent sponsor. Yeah, obviously it will prevent, but how do you do that? You cannot restrict contract from receiving tokens. You can restrict contract from receiving ETH. But tokens, if you remember, you guys went through the ERC20 chapter, the tokens are being stored actually in the token contract, not in the proxy contract, in the balances, in the storage of the token contract itself. So we cannot prevent others from receiving tokens. So the recommendation here just doesn't make sense. This recommendation makes sense because if you can support more tokens, distributing more tokens, you can, if someone sent tokens by mistake, it can be solved. So I do accept this recommendation, but I think it's a low. It could be accepted as a low, but just this first recommendation is not feasible. Yeah, here people say about DOS, blacklist may have, I don't even need to go through the finding, you can get it by the title. So this one we got it, I think it won't be accepted. That's why I also thought about it, but then I did not report it. If it will be accepted, it will be a shame because I wanted to report it and I didn't. Lack of storage gap in distributor contract may result in storage slot collision. Well, it's not, I don't think it's valid, this one, Marzel, because there are no state variables in distributor, as you can see. There are no state variables. All these are immutable and constants. So maybe, I don't know. But since there are no state variables, there could not be a collision. You only have constants and immutables. Yeah, but I also thought about this direction, try to find collisions because we have proxy. It's not also an upgrade, it's just a delegate call. But they're not using any storage variables in the storage and distributor, which basically closes all the attack surface for storage collisions. Someone checked about SIGHASH function collision and couldn't find any collisions between the three contracts, which is also a cool attack vector and way of thinking. Yeah, but the thing is that they're not going to have future deployment. They're going to create new distributor contracts, and then they will need to audit these distributor contracts. So it doesn't really matter. It's going to be completely different contract. Organizer can maliciously claim funds of their own address or one. It's the same one as the first one. Vulnerable to front running. Wrong. It's not vulnerable to front running. We went through it. A lot of invalids one. Blacklisted winner, again, another duplicate of blacklisted. Rewards in the future when scales up. Oh! This is similar to mine, I think, guys. Yes, you see? It's the same one that I reported. The winners and percentages are not supposed to be so long, so loop can stay unbounded. Yeah, well, it cannot also. And we have a POC. Did he also add a POC? No. Maybe mine will be accepted. Open Zeppelin, two-step on. Yeah, there are not very interesting findings. I couldn't find anything interesting. It's all like very obvious things. But we will wait for the report and we'll see. Unencrypted sensitive data exposing sensitive information to potential attackers? What? Where there is sensitive data in the smart contract? Well, you see what happens when people don't think. What is this? I'm sorry, but what? Where is sensitive data being stored in the contract? Well, invalid. Yeah, I won't go through all the findings because only if you have something interesting, because then it's a lot of things, and this is why we have judges, and you also have the live streams that Patrick does when he judges. So if you want him to see how he judges and how we go through all the findings, you can do that. For me, I will just wait for the final report and for all the findings. I will be very interested to see what I missed. That's why I ask you guys to tell me if you see something interesting, if you reported something interesting, because it was very tight. But I'm sure there are more highs, medium hidden here. Very creative people could find them. And that's it, guys. I think that's about it. So we covered the results of the previous contest. We covered the Spark and Codebase and the findings that I reported. And yeah, that was our live stream. I hope you guys enjoyed. And if you have any questions, anything you want to ask me, anything you want to say, sure. It's my pleasure. I really enjoyed it. I love doing this small Codebase contest and then coming here, show you the way I do it, the thing I found. I would be more happy if you guys also participated and show me your findings. And I want to see how you progress, how you think, what knowledge you applied in the contest. It would be super cool. So next time, please come more prepared, like we did in the first live stream. I really like when you guys come and share your insights and your findings as well. But I also love your engagement. I like your engagement in the chat. Do it. Participate in the next one. I will also, like I promised, I will announce on Twitter and maybe also here in the Discord community, which is going to be the next one that I'm going to participate. And you can see here that I announced it. I also made a tweet about the fact that if we get X likes, I'm going to participate and make a live stream. So follow on Twitter to see if I'm going to participate in more contests. So you can also participate and we can do those live streams together. Yeah, this one you can see. What do you think? Should I participate in the CodeHack Spark and contest and create another live stream once it's over? If we get at least 50 likes on this tweet, I will consider this as a yes. And we got 136 likes, which is super cool. So stay tuned. If there are going to be more, I'm probably going to make a tweet and put a link here in the announcements or the chat. Yeah, Judah, great question. So at the moment, I'm working with external guest teachers to bring more content. I also myself want to create more content and add to the course. But my highest priority right now is the final exam. Now, you know what? If you guys, you are the 10 people that stayed, so you deserve some alpha. So I will tell you, the test is almost ready. There is a bank of around 500 questions on different difficulty level from all the chapters. So you really have to go through all the chapters of the course. It's going to be in the platform. It's going to be amazing. Probably 30 questions that will be randomly chosen from this bank. You will have some time to complete it, like multiple choice questions. And upon completion of the test, depends on your score, you're going to get either the limited edition certificate if you got above 80%, or if you got above 60%, between 60 to 80, you're going to get a normal certificate. If you got below 60, unfortunately, you're not going to get a certificate. Sorry, I will answer in a moment. You're not going to get a certificate, and you will have to re-go through the materials of the course and do the test again, and there is a time lock, so you cannot do it right after. We'll have to wait. So you really, you need to. You can take it only once, or you will have a cooldown. So if you fail the test, you will have to wait a certain amount of time. It's not decided how much time yet, and in order to take it again, but you will be able to take it again. It's not going to be. It's not going to cost any money, so it's part of the course. It's something that we promised, also certification. And more than that, I will give you a hint. We are working with other organizations. I'm not going to say names, but I will announce later that you're going to get, if you get the limited edition certificate, so if you're going to do very well in the test, you're going to get even other benefits outside of the smart contract hacking community, apart from the fact that it will be acknowledged by organization in the space, very known organizations that you know. You will also get other benefits and features if you are able to score more than 80% and get the limited edition certificate. So really, this is my main focus to complete it. It's a lot of work. You won't believe how much, not only to create the bank of questions, but also to test it, also to create, I don't know if you know, the whole system is based on WordPress, but all the tests and the certificate, it's plugins that either I developed or I use developers to develop it. It's all in-house. So if you will try to cheat, by the way, we are not gonna be we're not gonna forgive you. So there are a lot of systems that I myself develop in place that you cannot cheat, you cannot use GPT, and if you do cheat, the test will be terminated and you will have to wait X amount of time until you can do it again. So Really, it's a lot of thought and effort is getting into it right now. So you will have the best experience, and this certificate will be the most valuable certificate out there in Web3 security, and it will give you a lot of things as a student who achieved this certificate. So it's not going to be just another test or just another certificate. So this is for your question, Judah. And after that, probably will come more content for the course. Yeah. Any questions? Regarding the Viper contest, probably not, because I know I code Python, but I never tried Viper. And it will take me a lot of time just to get into it, and I don't have time because I'm focused on the test, on a lot of other things. There is also collaborations coming up with OpenZeppelin, with Codorina that I'm working on. Oh, very good question. Yeah, actually, I'm working right now on two similar opportunities. It's just in the talking, so no guarantees yet, but I'm trying to bring two more things like early mint to the community. Kind of auditing contest slash bug bounty. One of them is going to include Cairo smart contracts, which is a bit different than Solidity. So if you know some Cairo, you will have some advantage, or you can just grasp Cairo really quick and find logical bugs in the contracts. And some of them is something that I'm trying to do with OpenZeppelin, but we'll see. It's still in the talkings and in preparation, but it's work in progress. All right, guys. So I guess that's it. It was a pleasure. I really enjoyed here in this live stream to be with you and share with you my findings and talk with you and answer your questions. Thank you so much for being here. Cairo is cool. There are a lot of opportunities in Cairo, but don't learn it solely for this upcoming opportunity because it might not happen also. But yeah, it's very useful to learn Cairo because there is not many people that know how to audit Cairo smart contracts and Cairo security, and there is quite nice TVL in Starknet, so the demand is there. Now, thank you so much, and I will see you in the next live stream. Feel free to reach out to me, to write here in the chat. That's what this community is for. So thank you.